welcome once again to Code and Roy. Uh, so this is the part 3 of 4-part video series discussing the various solutions to the single element 2 problem. Um, 2 videos are already out. This is the number 3 of 4, right? So I just thought there would be 3 parts to this question, but I think because it's getting very lengthy, I have to break it into 4 parts. So this is the fourth solution that we are discussing. We have 5 solutions. This is the fourth one we will be discussing. And the question is that in an array, let's call that array A, all the elements are repeated thrice except for one element which just occurs once. Let's say if there are elements like this, so 3 is repeated thrice, 2 is occurring once, but 1 is also repeated thrice, right? So all the other elements except 2 are repeated thrice. So we have to report that 2 is the element. So we have to report 2 because 2 is the only element which is occurring once. That will be our answer. So till now, I highly encourage everyone to look at the previous 2 videos. The first video will be discussing the problem in detail, and we will be discussing a brute force approach using maps and sets and only maps. In this video, we will be discussing when in the previous one we had discussed a little bit about the problem statement and technique. So here I have written that down for you. So the trick learned till the previous video was that the answer will have 1 bits in those locations where the sum of the bits at that location leaves a remainder 1 when divided by 3. Here the sum is taken over all the elements of the array. As I had explained previously, I'll just give a brief recapitulation of what we had discussed earlier. So let's say array element A has 3, 3, 2, 1, 3, 1, 1. So what we will do, we will get the binary representation of each of the elements and write that down. Okay, so 3 is like 1, 1, 2 is like 1, 0. So there are 2 3s, and rest all there are actually 32 bits representing the binary form of the numbers. So there has to be 32 bits for all of this. The rest of the bits are 0 in case of all the numbers, right, that we have considered here, 3, 2, and 1. We will only have differences in the last 2 bits. So 1 we will have 0, 1, then and so on and so forth. So what we will do is that we will add all the bits at each position. So here the ones will contribute to the sum. So here if we have 7 ones, the sum will be 7. In case we have 10 ones at a location, the sum will be 10. Now once we get the sum, we say that at those places where the sum is of the form 3x plus 1, that means when we divide the sum by 3, when we divide, let's say, 7 by 3, we get remainder 1. So here at such locations where the sum is of the form 3n plus 1, at those locations we will have 1 in our answer integer, right? Our answer has a binary representation which will have 32 locations consisting of 32 bits, and this sum will also have 32 sums. So we will have 32 sums, right, for one for each location, from bit number 0 to from location number 0 to location number 31. 0 to 31, there will be 32 bits. So the wherever the sum is of the form 3n plus 1, those places will have 1 in the answers. Let's say at let's say bit number 10 and bit number 7, we have the sum of the form 3n plus 1. At those locations we'll have 1, at the rest of the locations we'll have 0. So that will give us the answer. So that is the trick which we learned, and I have summarized it in this paragraph. Now let us move to other statements. The So that till that we know. Now we'll know about the newer trick. Instead of finding the sum by looping, so for finding those 32 sums, we had to we had to get, we had to take an array, right? AI. So so the array was of 32, size 32. So in the question, if you see, they ask us specifically, can you do it without extra space? So for doing without extra space, we can use this trick. Okay. So by instead of looping, I should have written using extra space. We can use bit manipulations. Okay. How will we do that? Now we know that all the integers are either of the form 3n or 3n plus 1 or 3n plus 2. All the integers can be represented using these three. So uh, so the sum of the ith bit could be 3n of the form 3n or 3n plus 1 or 3n plus 2. The sum could be any integer. We are not saying that it is specifically a given range of integers. It could be any integer, but as all the integers can be represented using 3n, 3n plus 1 or 3n plus 2, the sums of all the locations from location 0 to location 31, all the individual sums could be of the form 3n, 3n plus 1, 3n plus 2, right? We are only considered about the 3n plus 1 location sums, right? The sums which are of the form 3n plus 1, at those locations our answer will have value 1 or the bit 1. At other locations our answer will have bit 0, the binary representation of our answer. We know that there are 32 sums, right? That we know. So we can have three integers that represent characteristics of 32 sums. So what I suggest is that, so we know that there are 32 sums, right? Each integer, so now each of the sum could be either of the form 3n or of the form 3, sorry, let me use a better ink, of the form 3n plus 1 or 3n plus 2. Now what I suggest is that I have 32, so now I have three integers, okay, one representing 3n, one representing 3n plus 1 sums, one representing 3n plus 2 sums. How they represent? So now each of the integer we know has 32 bits, right? So 3n will also have 32 bits, 3n plus 1 will have 32 bit representation, similarly 3n plus 2. What I suggest is that I will keep them as a counter or as a representation of the sums. All the sums which are of the form 3n, at those locations I will put 1 in my 3n representation. All the sums which are of the form 3n plus 1 till now, I will put 1 in those locations in 3n plus 1, and all the sums which are of the form 3n plus 2, I will put 1 at those particular locations in my 3n plus 2 representation. That means if I have 3n, I can say, like, if I have 3n, if 3n has 1 at locations number 8 and 17, I can say that if I do the sum of, let's say, the elements of the array, if I have taken sum of 5 elements till now and I do the sum, and in that sum I'm pretty sure I can say confidently that at location number 8 and 16, the initial two locations, I don't remember, hopefully those were 8 and 16, at those locations my sum will be of the form 3n, because in my 3n integer at those locations I have got 1. Similarly, if I've got 1, 8, let's say 0th and first position in 3n plus 1, I'm pretty sure that in my sum that I've got till now, at 0 and first position, my the sum will be at 0 location and the 1 location, the sum will be of the form 3n plus 1. Similarly for 3n plus 2. That is what I have written here. Let us quickly go through the things. I'm very going a little bit slow in this question and explaining everything because it requires a lot of thinking, and I feel that you should also um, pause in between and try to grasp all the concepts that I'm explaining one by one. It's very important. 3n represents that all those sums that are of the form 3n for which there is one bit in the binary representation. That I have already explained. So all those sums which will be of the form 3n after summing over, let's say, x elements, um, 3n integer will have 1 in those locations in its binary representation. So that is all I have written. So if at ith location the sum of bits is divisible by 3, the 3n integer variable will have 1 in its ith location and the other two will have 0 in their ith location. Right? Because any number which is of the form 3n, it will definitely not be of the form 3n plus 1 and not be of the form 3n plus 2. Right? So again, if I at any given point of time, if I sum if I do OR of 3n plus 1 and 3n plus 2, what should I get? That's a question you should answer. It's just not relevant to this question, but I think it should be understood, right? Write the solution in the answer, and I like those solutions, and we'll also connect through comments. We can discuss through comments. Write the answer in the comments section below. What will be the or result of ORing the three integers representing 3n, 3n plus 1 and 3n plus 2 at any given point of time. Also, these integers can be changed dynamically as we add new elements from the array A into our sum. This is a bit troublesome. Wait. Yeah. So what I mean to say is that let's say the array has got 4 elements, 1, 2, 3, 4. Now I don't mean to say that 3n will represent so what we do is that I will start initially my 3n will be 0 or all ones, because now till now my sum is 0, complete 0, right? I will start with the sum of 0. Now all these bits are divisible by 0, right? 0 is divisible by 3 also. So they are all divisible by 3. So they all are of the form 3n. So initially all my 32 bits will be of the form 1 1 1 1 1 1. And 3n plus 1 will be all zeros, and 3n plus 2 will also be all zeros, because initially my sum of the bits is all zeros. But as I keep on adding, I will go iteratively through all the elements in the array one by one. First I'll add 1. I'll see here there is a 1, right? So if currently my sum is of the form 3n and I have 1 in my binary representation in this location, so what should be the characteristic of the sum at this location? It should be of the form 3n plus 1. So I make it 1 here. And it is definitely not 3n anymore. So I make it 0 at this location, right? Similarly, so now my new 3n will become, so now my 3n and 3n plus 1 will become, so it will be like this and it will be like this. So the last element will change. 3n plus 2, there will be no changes because there was nothing in 3n plus 1 which was positive. Now you can see now if you add 1 here into our sum, the sum will have 1 of the form all zeros except the last two digits 1. Now if I see the sum characteristic, till the second last element, everything is of the form 3n. So we have ones at all the locations, but the last we have a 1 which is of the form 3n plus 1. So it is not of the form 3n, which is represented here, and 3n plus 1, which is of the form 3n plus 1, which is represented here. None of the bits sums are of the form 3n plus 2, which is again represented here. So I have written that. So what I mean to say is through here that we have to parse through the array, and while we are parsing through the arrays, we have to calculate the sum till ith element, like from 0 to ith element. This is how we increment our sum. So we will just loop through the array from I equal to 0 till I equal to n. right, or n minus 1, whichever it is, and by the time we'll reach n minus 1, we have calculated the sum of the entire elements of the array, and we have the characteristic of the sums stored in these three integers, whether the sum is of the form 3n or 3n plus 1 or 3n plus 2. That is what I have written here. Let's say we add a new value aj into our sum. We then find out the bits that are common between aj and integers 3n, 3n plus 1 and 3n plus 2. So common bits means that should be 1 in aj also, and that should be 1 in my one of these also. Okay, so common element. So here we found out that this one which was there in the last bit in one had 1 in the last bit, also 3n had 1 in the last bit. So we find out the common elements that are like 1 which is present in both the locations, right? So that is what I mean by common element. So common means that 1 should be present in both the current element which I'm adding into the sum, as well as the 3n, 3n plus 1, 3n plus 2 integers. We will store them in the common with 3 and these variables, common with 3n, common with 3n plus 1. These are the name of the variables that I've used in my code, and common with 3n plus 2. So we'll find out we'll basically do OR between all the elements, and at whichever places there are 1, our common with 3n will capture that, right? So common with 3n will have 1 in all those bit locations, wherein 3n was already having 1 in those locations, and my current element which I'm adding into this one has also 1 in those locations. So that will be common with there in common with 3n. Similarly, common with 3n plus 1 and common with 3n plus 2. Now, how do we update that? For 3n new, now previously you had a 3n, now we are adding, now as I explained here, previously a 3n was all ones, but now it has become, the 3n new has become all ones except the last bit, which is 0. So that will be 3n new. The set bits will be common with 3n plus 2, and the unset will be common with 3n, whichever were common, like 3n plus at those locations where the sum was divisible by 3n plus 2, and we are adding 1 because our element has 1 in those locations. At those places from 3n plus 2, if we do plus 1, it becomes of the form 3n. So that is why at those positions which were in which we have common with 3n plus 2 as true, that means 3n plus 2, the sum was divisible by 3n, was of the form 3n plus 2, and again my new element is adding or contributing 1 to the sum. Those locations I'll make 3n plus I'll make 3n new as 1, and which were already 3n, which were already divisible by 3n, but still we are adding 1, the new element is adding 1, that will make as 0. And so so that is how I update. So similarly 3n plus 1, you have to understand from the code. I'll give you the code, you can get. So 3n plus 1, where at which positions will it be 1? Common with 3n, whichever positions are there, that will be 1 in 3n plus 1, and wherever, and common with 3n plus 1 will turn those bits as 0. The rest of the bits will remain the same. Similarly for 3n plus 2, common with 3n plus 1 will be turned on, common with 3n plus 2 will be turned off. Okay, so initial condition 3n is all 1, as I've already explained, and 3n plus 1, 3n plus 2 are all zeros. Once we add all the aj's, right, the values in our array, one by one we are adding. Once we complete the entire array, 3n plus 1 will be the answer, because we see as in 3n plus 1 all those bits will be 1, for which the sum of the bits over all the elements of the array will be of the form 3n plus 1. I think you understood, right? That is the definition of 3n plus 1, and which is exactly the characteristic of our answer. The answer should be having 1 at those locations wherein after finding the sum of all the elements in the array, the sum will be of the form 3n plus 1, right? And that is exactly what 3n plus 1 does for us. So that is the solution. I have mentioned that in code very simply. So common with 3n is the P represents my 3n, so it is all 1 initially. TPO is 3n plus 1, TPT is 3n plus 2, which are zeros initially, and then common with 3n, common with 3n plus 1, common with 3n plus 2 are the elements that store what are common. You can find the, if I do AND with AI is the current element that I'm adding into my sum. So I'm traversing from I equal to 0 till n minus 1, as I've already explained. Now I'm finding the common in storing in those locations. Okay. So common with 3 I found out, common with 3n plus 1 and common with 3n plus 2. Now I am, as I have already explained, 3n will be zeroed at the locations which are common with 3n, and it will be 1 at those locations which was common with 3n plus 2. Similarly, the situation with 3n plus 1 and 3n plus 2. Finally, after I have traversed in the entire loop, I will return the 3n plus 1, and that will be my answer. Hope you liked the answer. I know I've gone fast because I wanted this video to be short, and you have to understand this thoroughly. Even if I have understood, made you taken 30 minutes, still you need self uh, uh, thinking and a lot of critical thinking to understand this properly. After this video also, you think about it. Any doubts, feel free to ask me in the comment section. I will be answering all your doubts, and if there are a lot of doubts, I will be making another video on this answer itself. Hope you liked it. I am Dinesh Monti signing off from Coding Roy. Thank you.